Hi, this is Jacob again. You have already programmed and or operations using normally open contacts. Now let's move on. Let's introduce to our ladder logic code normally closed contacts. Let's begin. Hello and welcome. In this lesson we will continue working with bit logic operations. I will show you how to use normally closed contacts in your ladder diagram. In this lesson, I will continue working on the same project from the previous lesson. If you want to synchronize your project with mine, you can download template, which is attached under this video. Okay, let's start with a little bit of theory. In this picture, you can see graphical representation of normally closed contact. As you can see, it is really similar to normally open contact. The only difference is that you have a little line inside this contact. It informs you that principle of operation of this instruction is opposite to normally open contact. Normally closed contact is closed conduct signal from left to right when the operand has signal state 0. In this case, when I 0.0 has signal state false. Normally closed contact is open, doesn't conduct signal, when the operand has signal state 1. With normally closed contact, you can form logical operation of NOR or NAND. Below you can see truth table for those two operations. Okay, now let's move on to TIA portal and let's write some code. Now I will show you practical application of normally closed contact in your ladder diagram. Okay, firstly, let's place a sensor in our factory I/O scene. As far, we have placed retro-reflective sensor with a mirror. Now go to Sensors and select the blue one. Place it before the orange one. Okay, maybe a little left and perfect. Now go to drivers and map this diffuse sensor. Drivers. We have to add some new addresses in input area. Go to configuration and change the value of 4 to 5. Go back. And now you have to drag this diffuse sensor and drop it next to the newly added address. Okay, let's go back to factory I/O scene. Now go to TIA portal, PLC tags, standard variable table, and we have to declare another variable. xsensor2. It is Boolean variable on the address I 0.4. Byte 0 bit 4th. Okay. Now let's check the difference between those two sensors. We have to start the simulation. Okay. Okay, I have to download the program and start the module. Okay, perfect. Now go to PLC tags. Go online. And turn on monitoring. Okay, now we can start the simulation. And let's move the box near the sensors. Okay, let's analyze the signal from those two sensors. The first sensor is the orange one. Now this sensor's signal is in high state, whereas the second sensor signal is false. Those two sensors work with different working principle. Diffuse sensor signal is in high state when it sees the object. The working principle of retroreflected sensor is opposite. This sensor's signal is in high state when it doesn't see the object. Now the sensor sees the mirror. When I move the object in front of the sensor, its signal is false. Okay, let's move on to write some code. Go to main OB1 and reset the simulation. Okay, now the task for you. Let's change the program so that our box will stop in front of the diffuse sensor. So far we have used this retroreflective sensor at the end of the conveyor. Now let's change our program so that the box will stop in this line. In previous version of our program, we used normally open contact with the operand as the retroreflective sensor's variable. Let's check what happens if we put in series. If you are interested in PLC programming, just enroll in our full PLC training. You will find the link down below this video.